All right, if you're here for the environmental noise webinar, you're in the right place. We'll get started in about a minute. There's a chat bar, should be a chat bar on the right. If you have any questions, feel free to write them down. I'm gonna go through this pretty quickly. It should take about 25 minutes, 30 minutes at the most. But if I go too fast or if there's something you want me to address, feel free to chat or type something in the chat and I'll try to get to that. Let's see, I assume my audio is working. Looks like it's on. All right, I think we're set to go. It's just a little longer. I'll give anyone else time to show up and then I'll get going. There we go. All right, so to respect your time and, oops, how do I get out of that? There we go. To respect your time, I'm gonna get started. It is 12 o'clock, and again, I'll try to get through this pretty quickly, but feel free to cut me off if you hear anything. Oh, thanks for the feedback. So I am going to be talking about just noise analysis, environmental noise, how we analyze compliance issues and mitigation. Sometimes we have people from quite different backgrounds, so I'll try to keep it pretty general, but if you have specific questions, let me know. Just a little background, I'm an acoustical engineer. NCAC is a good resource, National Council of Acoustical Consultants. You can find consultants around the country. Acoustical Society of America, it's more academic, not for consulting, not the greatest resource. Yeah, I used to work for Digisonics, Daily Stanley, David Adams, and Intranco, which got bought out by AECOM, and then started Sound Solutions, I don't know what that was, about 12 years ago. So the general steps: measure existing noise, sometimes predict the future or existing noise, compare with the guideline, and look at noise mitigation if it's justified. The projects for environmental projects, it'll vary depending on what the criteria is, what the guideline is, but this is general steps. A lot of times we're measuring the noise so that we can calibrate our model and make any adjustments. And sometimes there's no predictions. It's just measure, see if there's an issue and be done. Check to see if it meets the guideline and move along. So some examples of projects. In Arizona, we do a lot of road projects. Anytime they do any changes to the roads, they need to do a road study where there's noise sensitive receivers in the region of the road. So if there's homes, schools, parks, they require us to do a noise study and determine if noise mitigation is justified. Airports, we get a lot of projects in San Diego. If you build in the airport zone, that 60 dB day-night contour that the airport comes up with, or that we come up with, that someone comes up with and that the airport publishes, if they're building in there, a lot of times they need a noise study. And that involves usually just looking at what zone they're in, what exterior building construction they're going to have, and if it meets the 45 dB day-night noise level criteria inside. Are they providing enough mitigation with those exterior components? Commercial, industrial noise. A lot of time that just involves, in Arizona, well, complying with the guideline. If there's an issue, sometimes the industrial contact doesn't say, hey, we want to do this or that. We're worried about it might be an issue. Could you measure and then predict when we make these changes to see if we need mitigation? Or it can be there's an existing issue and one side or the other wants to measure and do some mitigation. The Department for Housing, Urban Development, if you're building a HUD project, which is subsidized housing, or you're getting funds from HUD to build this housing for, a lot of times it's multifamily housing, then many times they'll require a noise study, and they're usually just looking at transportation noise, road noise, airport, train, and they have all the programs free on their website, so you can do these analyses using their software and determine if it meets their guidelines. And they're real general. It's similar to these airport studies. You're looking at exterior construction and how close they are to these different sources. So regulations, this is what drives the study. Some regulations will require that you measure the noise. Some regulations, they don't even care what the existing noise is. Some regulations are very well thought out, very careful, or very detailed. There's no really leeway, like the Department of Transportation, FHWA, or each state will have a Department of Transportation, each city or county, depending on who's funding the project or where the projects are coming from. They spell out real clearly what the criteria is and the steps you need to take. You can only measure when the roads are dry, when there's this much wind. You have to measure for 3 10-minute periods during peak traffic hours. And they're real specific about the measurements that they want. You use their software, T&M, for the predictions. And they're very clear about, all right, if it exceeds certain levels, then you have to look at mitigation, but then you have to go through the steps of determining if it's justified. So that's very clear. Some, for other types of projects, not necessarily transportation, it can be a little more vague. Arizona doesn't have a state regulation. There are some states with regulations like Colorado, Oregon, Massachusetts, I know Utah. There's a state limit, makes it real clear everyone follows that same limit. In Arizona, we do it county or city, city by city. And some of them have most of them have very unclear limits. In Arizona, a typical noise limit would be 55 decibels, an average level, like an LEQ, an average level during an hour, and maybe 50 at night. In Arizona, there's counties that just say if it's audible inside when your house is closed, that's a violation. Some of them say if it's a disturbance, that's a violation. And that makes it difficult for everyone involved. It makes it difficult to put up a cell tower, it makes it hard for us to comply because we're not sure, well, is it audible? What kind of windows do they have? What kind of construction do they have? Is it a nuisance for this person? You know, there's varying, people have different, I guess, perceptions of noise. And so it's not all that clear. I think this is looking at the airport, or is that the TNM? Yeah, this is the TNM software that they use, or that we use, to predict road noise. It's really clear. It's free software. You put in the coordinates of the road, XYZ of roadways, XYZ of receivers, XYZ of barriers, put in the amount of traffic, the speeds of the traffic, and it churns out what the levels are and if you have to worry about it. Airport contours, this is what I was saying, if you're constructing in these zones, there could be issues, or you need some report saying that you're going to be okay with the construction you're proposing. And then there's also, for predicting these, you're plugging in the types of aircraft flight paths and you come up with these contours. This is the software to do that. You're putting in the flight paths, the traffic volumes and types of traffic. Some traffic or some noise sources are exempt. Rail is exempt, but cities want to be good neighbors. Cities want to be good to their constituents. But rail, heavy rail, we have a lot of that here. That's exempt, but sometimes in a home or in a company wants to mitigate against it. So they can't necessarily force the trains to stop tooting their horns or to go slower or faster, but they could provide some mitigation to protect themselves. Some cities do have 24-hour average limits. We have a city here doing that, Mesa, and it's tough. You can make all the noise you want. You could jackhammer away for an hour and then be quiet for the rest, and you're in compliance. And you could be jackhammering at 3 in the morning, and you'd still comply. Yeah. Okay. So let's hit. I don't know if you have any questions about the policies. There's a big variety, and that will drive how your noise, your study is conducted based on what they're requiring. So here, when we're looking at reducing noise levels, we're looking at reducing the source, attenuating the path, or treating the receiver. So treating the source would be, an example is replacing, do I have notes somewhere? Replacing the equipment, get newer equipment, maybe get 2 units instead of 1 large unit and space them out, silencers on the units, maintenance, upgrading belts, some of that. With the source on a road project, we use something called RAC, rubberized asphalt concrete, which helps a lot with that wheel road noise. And as you can imagine, on flat roads where it's mostly autos or cars, you're doing some pretty good attenuation. You can get up to 10 dB noise reduction. You could cut that noise in half, do really significant noise, and not even need to build barriers. If there's an incline or if there's heavier vehicles where you get more engine noise, it's not as effective. And what they've also found is it's costly because every 2 years you need to perform maintenance as opposed to normal asphalt. It's more like 5 or 6. So it's a cost and a nuisance. They're playing with different mixes. I don't know, these little terminal grades that are a blend of just normal asphalt with this rubberized asphalt to try to make the maintenance, make them last a little longer. And they're not quite as effective. But and ADOT, or Arizona Department of Transportation accepts rubberized asphalt as a treatment and allows you to reduce the noise by 3 points in your model, no matter whether it's hilly or no matter what the mix is. So each Department of Transportation will address that differently. There's some that don't include it at all or don't allow a reduction for it. At the source, noise, again, silencers replacing equipment. Treating the path, we don't have too much magical solution. We get called now and again for some active loudspeakers to just cancel and make silence. We don't have that as an option right now. We use walls. The higher the wall, the better. The walls need to block the line of sight between the receiver and the noise source, however high that is, whether you're doing the road, wheel road, the engine. If it's trucks, it's going to be a higher noise source. But between the ear, and we usually use 5 feet above the ground, between the ear of the receiver and the noise source, if you're not blocking the line of sight, you're not attenuating the noise. So you need to block the line of sight, and the more you block the line of sight, the more the noise is reduced. And a rule of thumb is block the line of sight by about a half foot, you're getting around a 5 dB reduction. Every foot that you increase, you reduce the noise by about a half dB more. And that's a real rough number, because the lower the frequency of the noise, the more easily it diffracts over barriers and the less effective barriers are. So if it's higher frequency, you'll get more attenuation. But in general, block it, you'll get some. The higher you go, the bigger, more you block it, the better. They're also most effective close to, where are we? Close to the noise source or close to the noise receiver. The more you're bending the path, the better. So putting a barrier in the middle is the least effective. And the further you are from the source or receiver to, the more ambient conditions, wind, temperature gradients will affect the noise reduction. So it can be any material. We're usually, if you're trying to reduce the noise by, let's say, 10 dB, it doesn't help you to have a barrier with a sound transmission cluster where the noise going through it drops the noise by 50 dB. Most of the noise, if you're going to get a 10 dB reduction from the height of the barrier, most of the noise is going over that barrier and not going through it. So it's overkill to provide, if your target's 10 dB, to provide more than a 20 dB, they call it STC, but sound transmission cluster, the amount of noise going through the barrier. So you could do wood, you can do block, you can do, transparent, some kind of acrylic material. As long as that STC is, more than the amount of noise reduction from over the barrier, you're going to be in good shape. Then you just look at cost, maintenance, what makes sense for other reasons, not necessarily for the acoustics. Receiver, treating the receivers. We don't have a lot to put earplugs in, isn't always everyone's favorite solution, but you can treat in buildings. They do let us, if barriers aren't going to work, or if there's issues on higher floors, treating windows can be a way to mitigate, or soundproofing booths. I guess this isn't environmental, but it's an example of, you have a noise source. You're not treating, you're kind of treating the path, but you're not really putting up a barrier. You're not treating the source. You're really worried about just where the people are working. All right. Again, let me know if you have any questions. I'm going to run through a couple examples that I think give a feel for some of the projects or some of the issues, how you go about dealing with a project. So this is one we did a couple years ago, Canyon Mine. It's near the Grand Canyon, and it's a uranium mine, so that brought up a lot of issues for people just worried about mining uranium. It was questioned what the noises were there. There's actually several miles before you get to residences, but there was a tribal ceremonial grounds, I believe, a half mile away. And so that's what we were looking at as our noise sensitive receiver. And they did put a noise limit on that, and we're worried about what the levels were. So we started by, we want to know what the levels are. We wanted to make a model of the site. So we could go out a half mile and measure, and we did, but we didn't hear much from the mine. And we're only measuring on one particular day with one particular environmental atmospheric conditions. So we wanted to say, all right, let's see what the noises are so we can model in every direction, because we don't want to go to 1,000 points to see where the noise is. We'd like to come up with a model saying, hey, at 1,000 feet or 500 feet or at 100 feet, here's the noise coming from this equipment, from this operation. And then we can just, a general rule of thumb is every doubling of distance, the noise goes down by about 6 dB. So if we get far enough out, we could treat it as a point source and we could just estimate or model or predict what that reduction is. So we first want to identify all the sources. So we had some equipment as sources. We had them dumping the aggregate that they're sucking out into dump trucks as a source. And this is I forget what they call it, like a shaft mine. You go down a few hundred feet, put up a bunch of explosives, get out of there, blow it up, and then go down and drag everything out. And then, I don't believe they had screens and crushed on site, but they shipped it off for processing. So we had to identify, and if we know the noise level at a certain distance, at a known distance, at 50, 100 feet, then we can predict it further out. Yeah, the mine here was the Sacred Land hilltop, and I believe the mine was pretty far away. It could have been more. This does look like more than half a mile, like maybe a couple miles, but we couldn't hear a thing. They were running dump trucks in their front end loaders and moving aggregate around, and we couldn't hear anything from the site of concern. But again, someone could come back and say, hey, but in the winter when it's cloudy and the wind's blowing from some direction, it's actually pretty loud. And so we wanted to have a backup and a model and say, all right, knowing what the noise levels are of all those sources, here's what we predict, here's what we measure, and here's the issues. So we actually ended up, they even did the explosions, and I recall you could see a little puff of smoke, but they were far enough down that you couldn't hear anything. We couldn't hear a thing. I had to have radios so they could just tell me when it even went off. Another project, wildlife acoustics. Again, we're just dealing with whatever the regulations are. In this case, we're dealing with sage grouse who make a noise to attract a mate. Other noises from gold mines or mines can interfere with that mating call and interfere with this protected animal's reproduction. That was the issue. We got brought in by the Nevada gold mine to make sure that there weren't disturbances, and if there were, to make adjustments. And the BLM had jurisdiction. Now, there isn't a clear state or regulation that said, hey, you can't make more than 50 dB for whatever it is. So we just had to dig through the most recent published information, and there was a professor from Berkeley, Petrocelli, who had some papers. They'd been doing some studies on oil, extraction oil, what do they call it, oil wells, and or piping, I guess, from oil facilities. And they said that, hey, measure the existing, and I'll go over what statistical noise levels are, but the L90, this ambient background noise level before the mine's even in place. Then when the mine's going, hey, measure this L50, the kind of the average or the mean noise level when the mine's operating. And you only go where they breed, these leks. And we only care about it during mating season, and we only care about it in the morning. That's when they're most active. And just don't make sure the L50, that average, is no more than 10 dB above the L90. And no people can be near it, because that's going to disturb the birds as well. So a lot of criteria they threw at us. We had to measure, and if there were more than 7 exceedances, or more than 7 times that the level violated this guideline, and we couldn't explain what the noise sources are, then the mine's done. They are shutting them down, or at least shutting one access road, which was the primary noise source. And so we identified the noise sources. They measured. Yeah, and this is in the middle of the mine's on the other side of this little hill. I mean, it's in the middle of nothing. But the birds are in these nesting areas they call leks. So statistical levels, you're standing out there measuring, or the thing's measuring, and we had to do this all remotely, and it's cool. You can do unmanned measurements. It's just a little tricky to figure out what the sources are because you're not there listening saying, oh, that was someone shooting or that was a car going by. You're just looking at these levels, and we had recorders out there. So when we saw violations, we could actually listen if we needed to. We also had a little weather stations, and most of the time violations were wind related. Or they were from the bird themselves making their mating calls were causing exceedances. So to come up with it, you're measuring, you measure levels, you can see it's going up and down, there's more or less noise, then you sort this all out, put the lowest noise level during that period, usually an hour, during that hour or that 10-minute period, whatever the period is, you take the lowest to the highest. And then what we do is say the lowest is called the min, highest is called the max. The amount that's exceeded 90% of the time is going to be your L90. The amount exceeded 50% of the time, so that's your mean, not your average, but your mean is going to be called the L50. And you got L10s, L5s, and you'll see this in regulations all the time. The sound level meter does all this calculation, so it's not like you're sitting there sorting it by hand, but just so you can see kind of what it looks like. And then we had to correlate during the hours of interest, during the time periods of interest, had to correlate wind speeds with when that makes for an exceedance and when we could discount it and say, oh, this went above, but we don't really care because it's wind related. We had a lot of wind that day. We could also try to plot, this is the frequency, low frequency being deep, low noises with high frequency being higher noises. And after, sorting through data for a few seasons, you get used to what is a bunch of birds making noise, what's a bunch of wind making noise, what are just localized events, some animal or a cow chewing on the sound level meter windscreen, and you can sort those out. Now you have to have enough evidence that the people approving this sign off on it. So we had to convince the BLM for every exceedance that, it was not related to the mine. And sometimes it was mine related. And then we had to make adjustments, speeds or traffic or something. They had an L50 regulation. So you can see here, again, they're trying to protect the bird with an L50 regulation. We could have had a bunch of fireworks out there for, if we're looking at an hour, which we were at that time, or with that project, for 29 and a half minutes, or 29.9 minutes, we could be blasting fireworks right next to the lek. And then as long as for the rest of the time period we're quiet, we could pass. So the levels could be huge for the most of it, but the L50 is going to grab that mean level. And as long as the rest are low, you're passing, you're in good shape. So it's a kind of weird criteria. And just to point this out, the LEQ is this energy average. So you average all these levels. You actually have to convert them to pressure, just unravel it, add all the pressures, divide, and then log it back into sound levels, or dBA, or dB, whatever you're working with, but dBA. In this case, in environmental cases, is usually A-weighted levels, which are weighted for the human ear, which is mostly what we care about. So that's how we were trying to sort the data from remotely. I was sitting in Tucson looking at data from Nevada because they didn't want anyone out there. And we could tell, oh, this is kind of bird frequencies. This isn't from mining activities at these high frequencies. And if we have a couple sound level meters out there, we could also tell, oh, this occurred at one of the locations, but it wasn't a global event that we could attribute to the mining activity. I think that's all I wanted to get into with this. There's lots of ways you can sort these out. Okay, that's all I have. We are acoustical consultants. We deal with anything acoustical, industrial noise, product noise, expert testimony, We actually are providing treatments in Mexico now. We do in the US have DBE status, which gives us some help for a project. If it's a government project, we could help you get, I guess, a little bonus when you're trying to get your projects. I think that's all I want to do. We have offices in, I didn't put this on. Yeah, Tucson, Phoenix, San Diego, Las Vegas, and now in Sonora, Mexico. But actually in Mexico, we are all over the place. That's it. Any questions? I'll actually stop the screen sharing. Let me type in, I'll give you a couple references here. So NCAC is a good record. Oh, Randy came in. Okay, great. Oh, thanks. I'm glad you got something out of this. NCAC is a useful resource. ASA is a useful resource. NCAC is a good one to find consultants. INTS is a good one, Institute of Noise Control Engineering. Again, these tend to be a little more academic, but equipment you need, I get asked a lot, a sound level meter. And then we a lot of times use a loudspeaker for generating noise, so we can predict, so we can measure what the noise reduction is for like a construction, for exterior of a building. Sometimes we need audio recorders, digital recorders, and those can be remotely accessed. It can be expensive if you're in the middle of a cow field, but that's an option. We've used acoustic cameras, which you don't need. They're real expensive, but you can rent them. Excuse me. So for some projects, they can be useful for identifying noise sources. They give either videos or still photos. Let me send you to the ebook. I don't know if that went. Redirect them now. Okay. I will put a link here. This is the link to the free ebook. If you click or cut and paste that should get you to the ebook. If you can just click on that. Okay, yeah, you can click on that, and that'll get you to, you can download the latest version. I updated it recently with some new product suppliers. Okay, feel free to contact me if you have any questions or need anything. Thanks for joining me. I appreciate it. Bye.